Hi everyone, welcome to Code Kamikaze YouTube channel. I hope everybody are doing good. In the last videos, we had seen how can we make sure our infrastructure stay away from vulnerabilities and security flaws by integrating you know, different ways of security scanners into our environment. And we had scanned our source code for different aspects and find the vulnerabilities, and we had seen what all solutions are there for fixing. And as parallel to the DevSecOps playlist, today we are going to discuss about a concept called as scanning Kubernetes manifest file with the amazing tool called KubeLinter. So in the last video, we had seen like how can we scan or a Docker image and how can we find the security flaws. Since you are using microservice architecture, so you need to create your um, entire application as a microservice. For that, most of the companies had been using Docker. So if your application has been running on Docker and you do require a container orchestration for your Docker containers. I mean to say that, let's say example, you have the 10 to 15 microservices. So you do require a controller, a manager, whatever you call it. So to controlling all the Docker images or Docker containers on runtime. So that's why Kubernetes is more famous for that. And in the current world, since it is open source, is widely used in the realm in the current market. So if you want to deploy your application via Kubernetes by using Docker container, so most probably regularly you might write the Kubernetes manifest file, such as Kubernetes deployment files, service files, ingress, and config maps and secrets. So regularly that's the responsibility of DevOps engineer or sitting with the developers, understanding the requirement, how many parts or how many replicas he wants, and what is the endpoint URL, and which image he wants to use for deployment. So persistent volume. So these are all the basic information that regularly we passed via Kubernetes deployment. And so while you're writing the Docker, I mean, while you're writing the Kubernetes manifest file, so somehow you might dip down into some flaws, saying that you have not been following some best practices of Kubernetes. So that's why, like, even if you have not been following the best practices, so we have a tool to let you know that, hey, you have written the Kubernetes manifest file. That's amazing, but you have forgot to keep some forgot to add some best practices into it. So that's why I'm here. I'll scan your all manifest files and I'll let you know what all best practices you have to follow to stay away from security issues and kind of any other activities into your environment. So that's why we bring the KubeLinter. So KubeLinter is an amazing tool, I know, and it's open source tool which is developed by StackRox. In general case, it is adopted by Red Hat, and it can analyze the Kubernetes manifest files, and even it can be used for helm charts and identify the misconfiguration and security concerns. So what kind of misconfiguration you had not been following, and what is the best practices to write your manifest file, and it can suggest everything, and it can show are there any security concerns, are there any security flaws into your Kubernetes manifest file, and it can check your configuration against a set of best practices and common guidelines for security and performance, as we recall the same point as we just discussed about it. So it checks everything, like it checks each and every component of your file, and it will give the report what is the best practices and what all best practices you have not been following. And other than this, like, why we need to use the KubeLinter. So ensure the Kubernetes applications are deployed following the best practices and security guidelines. And we can integrate this tool with the ci pipeline for automating checks, improve our code quality and security posture before deployment. As we have been following the DevSecOps best principles and security tools integration to CI/CD, so this is also like KubeLinter can be integrated to your CI/CD pipeline, and you can automate this via CI/CD pipelines. Once you push your code into any kind of source code management, from there all the security tools can be activated. It can scan it and it will come at the end, which is KubeLinter. Even KubeLinter can do its job, and it can give all the reports what all best practices and what all best practices are not been following. And it's offered a flexibility with customization checks and tailored analysis. That's true, since it is open source and it has been um, gaining more popularity. It has good support in the market, and you can utilize it, you can trust it. So we have installation of Kubernetes, KubeLinter and Ubuntu, and we'll see what is the basic uses of KubeLinter, and so when you see the advanced feature, so it can check the custom checks and you can integrate the CI/CD pipeline. If you are using any customized Kubernetes manifest file that you ask for the requirement, if you customize it for deploying into your environment, so it can check it and it can give the best practices and all. So it gives the regular scanning. It can custom configurations, encourage viewer for explore custom checks, configuration align with the kubelinter with the security operational standards. That's true. And community engagement, as I mentioned, so I mentioned how user can contribute to kubelinter project to seek help to community and advanced use cases. So as I mentioned, like it has a giant amount of community support where you can go and communicate to the community. You can contribute to your kubelinter community and all. So this is the basic information about KubeLinter, where you can use it for scan your Kubernetes YAML files to identify the misconfiguration security concerns. So let's go deep dive into the KubeLinter installation on Ubuntu and how can we install KubeLinter on Ubuntu and how can we scan, a repository or any file into KubeLinter and what all procedure do we need to follow. So let's deep dive into it and we can see how we can install it and how can scan it. So stay tuned until this video. Oh, let me open the basic steps. So I have come up with a few steps, like what all steps do we need to follow for installation. So first we need to download the release and we need to extract the binaries and move the binaries into the particular path and we can verify the installation, and after you can scan the manifest file. So let me download the you know releases, which is more for this kubelinter. So I'm at home shake. Okay, so I'm just press enter. It connected. Oh, my bad. What went wrong? Not found. Let me check and get back to you on this. Okay. Um, I have found that there is a release issue. There is a release version issue. So I have changed it from 0 dot to 0.2.5. So let me take it. Let me download the all the uh, binaries. So I'm going to make a folder here, mkdir cube. Cube is my folder. So I'm going instead of cube, which I will keep all the binaries over here. So I'm going to clear up. If I do ls, I don't have any binaries has been downloaded. So I'll put this command and I paste over here. So it has connected now and it is going to render all the binaries, which is star.gz, which is more related to kube-linter-linux. Okay, so it have a render. Let me extract the binaries by taking up this command. I've extracted it and let me move these binaries into user local bin, and I've done. So now the installation has been completed. So you can verify the kubelinter version. So no, we are at 0.2.5, which we referred over here at the binary. So 0.2.5. Awesome. So we have successfully installed the kubelinter into our Linux environment. Now we would like to scan the manifest files of Kubernetes with the kubelinter. So for that, I've been referring to one GitHub page, which is Ashok Kid School. I don't know who is this guy. I went randomly to GitHub. I just have referred few manifest files out there. So that's why I'm just referring these all the folders, which is horizontal part auto scaling and EFK and config maps, blue green deployment, and RCS. So we have a bunch of files are available. That's why I'm just cloning this repository from GitHub into my local. So if I show you, Um, I have only KubeLinter binaries I have available. So just clone git clone. I'm cloning all the repository. Now it is getting cloning to my local. So if I do ls, so I do have Kubernetes manifest files. If I go into the Kubernetes, okay. If I go into the Kubernetes manifest files, we have the bunch of folders are available. So since our main agenda is to scan our Kubernetes manifest file with the KubeLinter. So KubeLinter is going to tell, hey, you have not been following few best practices or not, or are there any security misconfigurations have been added into your manifest file. So for that reason, we need to scan, or we need to get scan our manifest file or folders with the KubeLinter. So since we have installed the KubeLinter into our Ubuntu, and we have the source code, which is Kubernetes manifest files, or you can call as Kubernetes deployment file, or you can call it Kubernetes definitions files, as up to you. So now I'm going to call the command, which is like, if you want to um, go scan your Kubernetes manifest file or folder, you just need to specify kubelinter and lint. After that, you need to specify, you can folder name or something. I'm going to specify. I'm going to scan the 02 blue green model. Before that, I would like to show you what all do we have with this 02, what all information we have with the 02 blue green deployment model. So if I go inside, we have the blue deployment.yaml, live services, and green deployment.yaml. Since they have been following the blue green deployment strategy while they're deploying into Kubernetes, that's why they have a separate manifest file for each environment. So let me read a few information about blue, and we can start scanning. So if it is a deployment file, they have the RPA version, and Kinesis deployment, they have the metadata. They are going to create two pods, and they just strategy which is rolling update, and they have the Java based application. They have been specifying color as a blue, and these are the metadata. And if we come here in the specification, they are going to specify the container information, which is Java app container, and this is their image. They have customized it, and image pull policy. They're exposing with the 8080 port. So as regular, they have been specified the deployment file, but we just our requirement to our requirement is to scan this all this code which is written in YAML file, YAML syntax, and need to find the best configurations. For that, let's me come down, and if I see do ls, so we are at the right path. So I'm going to take the kubelint command, and I'm going to pass the folder name, which is 02 and blue. So this command, what it will do, it will call the kubelinter scanner, and it will take the entire 02 blue green model folder, which is whatever files are available inside of the 02 blue green model, and it will scan it. It will show you the best practices. So if I press enter, wow, it's very quick. If you see here, found 14 lint errors, so it's saying that, hey, we have a 14 misconfigurations are present in your this folder. So let me zoom out. We can read it. Wow. Oh, it's too bigger information. Oh god. So what I can do? Let me do. I'll scan it. I'll dump this entire information into one file. So, and we can, let's see if it is possible. We can get into scan.txt. So if I do ls, we have scan.txt. Awesome. So if I do cat scan.txt, if I do, oh, I think even it is showing the same information. I've dumped the entire information into one file, but the syntax is too bigger, man. So let me come up with the original syntax. So if you see here, the first error, it's showing that no namespace. It is finding the app version when kind deployment, and it's showing this 01 blue deployment.yaml and 02 blue deployment.yaml. So it is specifying the both files, and it's showing the kubelinter versions, and it is showing like object has two replicas but does not specify interpod anti affinity. So they have not specified any anti-affinity, and check it is giving you some information. Hey, check no anti-affinity, and this is a remediation which is specify anti-affinity in your pod specification to ensure the orchestrator attempts to schedule a replicas into different nodes using pod affinity, and specify the label selector that matches pod for the deployment. So they have given some remediation which is not follow in this 01 blue deployment and 02 blue green model. So that's why they're giving some remediations. And if you want to get more information, so they're giving some references. Let me copy this reference, And let me go to my browser so I can paste it up here. Wow, redirected directly into Kubernetes official documentation. Amazing. So it is saying all the same information what it has been specified. Interpod affinity and anti-affinity allow you constrain which nodes you can pods can schedule based on the labels of pod and all running on that node instead of the node labels. So that's the best practices. It is saying that it have to be specified into the other nodes line instead of single label. And this is the definition file they have been specifying, and you can follow this definition file and you can rectify your best practices. So that's the first one. And when it comes to second one, it is saying container Java web app container does not have a read-only root file system. It is saying that hey, whatever container you have, like it does not have the read-only root file system, and it is saying that check read-only root fs, and this is the remediation. Check read-only file system to the true in the container security constant. And this is all the best practices while you're writing the manifest file. And you need to specify no read only root for file system and root file system and all. And blue green model, this is the same file, and it is specifying container Java application is not set to be run as non root user. This is the main critical, guys, like whenever you are running your container, you should run as non-root user. So in generally people do forget to run as a non-root user. They directly run it as a root user. If attacker have gained the access, so he can do whatever he want into your container in your infrastructure. So that's why it's the best practices to run as non-root user. And if you want to get more information, so we can copy this link which is specified by KubeLinter. Let me come down and paste over here. So it is saying configure security for a pod as a pod or a container. So it is giving basic information. So how can he run as a non-root user and all, and you can follow security context, run as a user, run as a group and FS group. You can specify into specifications and all over there, and it's just basic information. Other than this, like you can use a security context as allow privileged escalation as a false. So you can follow these all documentation for make sure to resolve such a issue which is non-root user. So currently, this container has been running as a root user. So that's why they have given a best practice as hey, run your container as a non-root user. And the next one, container Java web app container has CPU request 0, which means saying that hey, set CP request and limits for container based on your its requirement. That's 100% correct, and it's a best practices also. Because if you don't specify any CPU constraints or CPU limits, so what you usually do, like container can utilize all the resources of pod, and pod can utilize all the resources of your node. So it's not a best practices, right? You need to left some space for other pods or other containers. So that's why you can share the resources as per the requirement, as per the request from the user. So in best practices, what people usually do, that they can specify CPUs at 1 GB and 1 or 2, and after that they can specify the RAM and 2 GB or as per the requirement. But it's the best practices to specify your resources and limits into your manifest file. So in this case, they have not been specified. Let me go to this URL. We can find more details on it. If you come down, you can see the pod definition. Well, if you see here, like they have specified the resource. This is a request, memory 64 MI, and CPU is a 25 MI, and this is the limit. They have been specified on the limit. Hey, we can go up to 128 MI, and CPU is a 500 MI. So this is the best practices guide, like while you are running your container, and they have specified the another image, like this is the image. They have given the same information for another image too also, which is this image will convert as a container. So it is going to utilize only these resources. It won't exceed this much other than these resources. So that's why KubeLinter has specifying this, like use the specified amount of resource and requirements into your manifest files. So that's all about, guys, like you can read bunch of more than 14 or 15 lint errors which have been specified into kubelinter, and I can follow it, and we can rectify all our manifest file. The reason why we need to integrate this kubelinter into your environment, because as you see, guys, like we have the manifest file. We had seen how the manifest file looked like, which was written by this into this github repository. But as per the Kubernetes documentation, they had not been following some best practices. Just how they have what they had been doing, they just had been writing the demand festival as per their requirement. But when you follow the best practices, right, you can stay away from the misconfigurations and you can stay away from the security flaws. As I mentioned just now, we had seen the CPUs and RAMs. So what happening, like, if you have not been specified any CPUs and RAMs, or if you have not been specifying any auto scaling in your environment, so these pods and containers will utilize all the resources into of your node, and it won't let other container can utilize. So that situation, what will be happen, the uh, other application which are running on other containers may not give a response in production or any other environment. So we may have a downtime in the application side. So that's not a best practices, right? So we should run our application with a zero downtime. That's why we brought the DevOps best practices. So, and we had seen, like, even KubeLinter saying that, hey, specified your resource and limits and request and release into your Kubernetes manifest file. So that's the best practices. If we keep that, so if we keep those request and limits, so your pod are limited, so it can be used as much your specified resources only. It won't go beyond that. So if you have gone beyond that, like, let's example, your pod CPUs and RAMs has been reached 90%. So that case, what you can do as per the best practice, you can you can add the auto scaling groups in your pods, and it can scale up, like scale down as per the request from the user, as per the CPUs and RAM utilization. So in Kubernetes, we have the pod auto scaling, which is horizontal pod auto scaling and virtual pod auto scaling. So this is how, guys, like, and you can follow the best practices, and you can keep your entire infrastructure sanitized to save from misconfigurations and security flaws. So that's it for this lecture into KubeLint, and we have amazingly completed all the tools which is required to integrate as a DevSecOps as a pipeline into the CI/CD pipeline, and we'll discuss all these tools and how we can integrate into our CI/CD pipeline in the upcoming sessions. And whatever we have done, the activities, like, we used to go and install it via command line and all. So in CI/CD pipeline, we don't do that. So we pre-install all the tools into the targeted runner. And what we usually do, we integrate this all the commands into CI/CD um, declarative pipeline or YAML pipeline that you regularly used. So from there, you can scan all your source code with these scanners like SAST, DAST, and image scanners, and we have other scanners that we have discussed, right? And accordingly, you can stay away from your vulnerabilities. If your pipeline had picked any one of the security flaws or errors, so what regularly do, we can stop our pipeline. So, and we can go and look at the issue regularly, like, and we can go and sit with the developer, and you can understand what was the issue, and is it code issue, or is there infrastructure issue, or is there any scanner issue. So those things we can discuss in the future session. So stay tuned for this channel, and please subscribe to my channel, and share to your friends. And until then, thank you for watching. Bye bye.